and I will be taking a lecture on classical integrands. It is a topic of integration, okay? And I will be covering the indefinite integration part of it. And I understand before understanding classical integrands, you need to have knowledge of integration by parts. Okay, no need to worry. I will teach you some basics of integration by parts so that once you get a hang of it, you get a hang of integration by parts, then applying it in classical integrands, it will be easy for you. Okay. So you all have studied islet thing, okay? Because the most important thing in integration by part is basically choosing the first function, that is u, and choosing the second function, that is v. And the order is like, if you have to choose, like there is a logarithmic function and there is an exponential function, then logarithmic function will be chosen as u and exponential function will be chosen as v. But I will suggest you not to cram anything like this, okay? Because once you get the formula integration of u into v, these are two functions, integration of this will be, you see u is as it is, we are integrating v, and here u is getting differentiated. So two places u has been used, one time it is as it is and second time its differentiation is taken, okay? And what about v? Both places v has been integrated. So out of the product of uv, v has to be chosen in such a way that its integration is easier and u has to be chosen in such a way that its differentiation is easier. Okay. Now I will give you an example of integration of ln x. We all know that we choose integration as antiderivative. But do we know the integration of ln x? Can we do it by method of antiderivative? We can do it by certain imagination, but it will be tough. The standard procedure to integrate ln x is actually by integration by parts. So how do we do it? You will say it is only one function. Where is u and v? It has to be two functions. So I have assumed ln x as ln x is equal to 1 into ln x. Okay. Now 1 into ln x. What can be done about ln x? Its integration is easier. No, we even don't know. That's why we are integrating it, na, ln x. Okay. So its differentiation is easier and its integration is easier. So what we have done, v has to be chosen in such a way that its integration is easier for us. So v is equal to 1 and u is equal to ln x. Now integration, what we do, u as it is, integration of v. So integration of 1 is x. Here there is a mistake, ln x into x, okay, minus integration differentiation of u, differentiation of ln x 1 by x and integration of 1, that is x. So 1 by x into x, 1, integration of 1 will be x. So ln x into x minus x plus constant of integration. Obviously we cannot forget about constant of integration. So we got that integration of ln x is x into ln x minus 1 plus c. I think you have got a fair idea of integration by parts. Now we can move to our main topic, that is classical integrands. So in classical integrands, actually I will tell you to observe these two patterns. Whenever these two patterns comes, what you have to do, you have to directly apply the concept and do the integration in simple 1 or 2 steps. Okay. And see, I am also not a very big fan of cramming and all. But see these patterns, I will teach you the proof, how actually this proof is done, and these proofs are done with the method of integration by parts only. And later if you remember these two patterns, it will be easier for you to solve the question. Okay. So what is the first pattern? First pattern of classical integrands, e to the power x into f of x plus its derivative. This function is sum of a function plus its derivative and multiplied by e to the power x. Then what we do is that integration of it, we simply write it as e to the power x into f of x plus c. Okay, first pattern got it? Please note it down. And now second pattern is f of x plus x into f dash x. And if we have to integrate a function of this type, f of x plus x into f dash x, we take its integration as x into f of x plus c. Clear? Okay, so I am taking one example for you. Like you have to solve integration of e to the power x sin x plus cos x dx. Okay, I am saying integrate this. Will it be easy for you? Of course it will be easy for you if you know the pattern. Differentiation of sin x is cos x. So this is f of x, this is f dash x. So integration of this will be e to the power x f of x plus c. That means e to the power x into sin x plus constant of integration. Never forget constant of integration. Okay. Now again one more example we can take. No. ln x plus 1. Can you integrate it? There is one way, like I have taught you what is the integration of ln x. So you can find it out by integration by parts, or if you remember you can write it down. And integration of 1 everyone knows. Okay, integration of 1 is x. So you can do it that way also, but I would prefer that now you solve it by using pattern number 2. Please identify pattern number 2. F of x, it's f dash x 1 upon x into x. That means the pattern is f of x plus x into f dash x. So we can write its integration simply as x into f of x. That means x into ln x plus constant of integration. Clear? Okay. Now you all must be telling we need to know the proof. Like we don't believe in cramming, so we need to know the proof. So I will teach you the proof, and proof is done by integration by parts only. That's why in the prerequisite I taught you some basics of integration by parts again. Okay. So first pattern 1 I have to prove it. Like if you want it, you can pause the lecture and you can try to solve it using integration by parts. It is not that difficult. This proof is not that difficult. Okay, shall I start? Okay. I can write it as integration e to the power x into f of x dx plus integration e to the power x into f dash x. Can we write it this way? Okay. Now leave this function as it is. Now all the operation we have to do, we will do on this. All integration we will do on this and using integration by parts. Okay. Now which function you will choose as u, which function you will choose as v? V is chosen in such a way that it is easier to integrate. Obviously easier to integrate. So this will be v, this will be u. Okay. Now u as it is, integration of v f of x, okay, minus integration of differentiation of u into integration of v f of x. We have applied integration by parts on this. Okay, now this was as it is. Now the magic. This has cancelled out each other. Okay. So what we are left with, just e to the power x f of x and plus constant of integration, obviously. So we have proved it. Okay. Now next, I will again suggest you to pause it and try it by yourself. Okay? Because same thing, same funda that we used in the previous pattern, same funda we'll use to prove this second pattern. Again, we'll do same thing, integration f of x dx plus integration x f dash x dx. Again, integration by parts, will choose u and v in such a fashion that v is easier to integrate and u is easier to differentiate. Okay? So this will be u, this will be v. Keep it as it is. Now, what we have to do about u? As it is. As it is. Integration of v minus differentiation of u, 1. Again, integration of v and a constant of integration. Again, same magic as previous one. It cancelled out each other and we are left with x f of x plus c. Okay, so we have proved it. Now, okay, note down the proof first, note down it. Now, some problems for practice for you. All you have to do is observe the pattern and solve it. Like in first problem, what we can do? E to the power x 1 upon x, okay, 1 upon x plus ln x. Have you observed the pattern? F of x plus f dash x. So integration of it will be e to the power x f of x plus c, e to the power x f of x plus constant of integration. Okay, solve the second one. Second one is a bit more trickier. Still, this is one I will treat it as very easy. Second, easy. Slight difficult than other. You need to know the property of logarithm. Okay, so what we'll do, can we write minus ln cos x, use the property of log, minus 1 will go in exponent, so it will be ln cos x to the power minus 1, that means ln sec x. So it is e to the power x tan x minus tan x, okay, plus ln sec x. Again, you will be amazed to know that this is f of x, this is f dash x. Ln sec x differentiation 1 upon sec x into sec x tan x. So this is f of x and this is f dash x. Integration will be e to the power x f of x plus c. That means e to the power x into ln sec x plus c. Now third problem. I'll rate it as a moderate problem. Okay, solvable. Okay, one thing you must note that pattern number 1 will not be recognized here, pattern number 2 has to be recognized here, and then it has to be solved in that way. Okay, and some trigonometric formulas are also, that's why I have rated it as moderate, because some formulas of trigonometry has to be applied here. Okay, one thing I am doing, I am erasing all of it. because this question will need space. Let me see if I have space. No, so I will have to erase it. Okay, third problem. What property you have to apply here? See, 1 plus cos x can be written as 2 cos square x by 2. Do you remember it, or have you forgotten the formula of class 11th? No, keep revising. Okay, all the formulas. So 1 plus cos x is equal to 2 cos square x by 2. Got it? So it is x plus sin x upon 2 cos square x by 2. Clear? Now separate it. Plus sin x. What to do about sin x? Sin x, write sin x as, since it has been written in half angle, convert it also in half angle. Okay, 2 sin x by 2 cos x by 2. Okay, 2 cancel out, cos x cancel out, so it will be tan x by 2. So it is x into half, let me write it properly, x into half sec square x by 2. Okay, this part plus tan x by 2, and we have to integrate it. Clear? Now recognize the pattern. F of x plus x f dash x, f of x plus x f dash x, integration will be x f of x, that means x into tan x by 2 plus c. Clear? So solved. Now the last problem of the day. It is a JEE Advanced Standard problem, very good problem. I would like to suggest you that please spare some minutes and try to solve it. This is a very good problem. Shall I start? Okay, I'll begin solving it. I know that I have to recognize here pattern 1, e to the power x some f of x plus f dash x. This can happen, but for that there is a pi by 4 which is troubling me. So what to do about this angle? That means we have to convert theta to 2 theta. Is there a method for this? This idea, this problem solving technique, is it clear to you? That we have to convert somehow theta to 2 theta. So when it becomes pi by 2, then we can eliminate that. Allied angle formula. Sorry. Okay. I have took a snippet of that in the next slide also, so that it is easy for me to solve. Okay. So we have understood till now that we have to convert theta to 2 theta. Now how to do it? Cosec square. So we know that sine square, that its reciprocal, sine square theta is equal to 1 minus cos 2 theta by 2. Okay. So cosec square theta will be 2 upon 1 minus cos 2 theta. Clear? That means cosec square, now theta, in place of theta put x plus theta minus sine theta. So this is 2 upon 1 plus sine 2x. Okay, so it is integration e to the power x something plus here cosec square x plus pi by 4 has become 2 upon 1 plus sine 2x. Okay, now I have got an idea again. What idea? That since it is a function in sine, so why not convert this tan into sine upon cos? Convert it, you will get 2 sine x upon cos x plus sine x. Okay. Now one more thing. 1 plus sine 2x can be written as cos square x plus sine square x plus 2 sine x cos x. That means this is cos x plus sine x whole square. Okay. Now which is f of x, which is f dash x? So we know one thing by quotient rule of differentiation, that when we differentiate this, denominator becomes square. Denominator becomes square. So I have got an idea that if there would be some f of x plus f dash x type of arrangement, this can be a candidate for f of x. Okay, so let's check, let's differentiate this. Okay, so actually I have differentiated it earlier only. So sin x upon cos x plus sin x, if you differentiate it, you will get its differentiation is as it is. Okay, so that means this is f of x, this is f dash x, so its integration will be e to the power x into 2 sin x upon cos x plus sin x plus constant of integration. Now compare it with g of x. So g of x is equal to this 2 sin x upon cos x plus sin x. We require g of 5 pi by 4. Put x is equal to 5 pi by 4. 5 pi by 4 is an angle of third quadrant. So at 5 pi by 4, sin x is equal to also minus 1 upon root 2 and cos x is also minus 1 upon root 2. So 2 into minus 1 upon root 2 minus root 2 and minus 1 upon root 2 plus minus 1 upon root 2 again minus root 2. So it will be 1. Okay, option number B is correct. So I think I have started the topic from very scratch. I taught you even the basics of integration by parts which was used, and then I took you to a JEE Advanced standard problem also. It is a problem of black book. Okay, so practice it, and I hope this lecture has added value to your JEE preparation. So thank you for your time. Thank you for your time. I will end the lecture here. Thank you very much.